Hi, everybody. I'm Alex. I'm part of the German Kong team here based out of Berlin. I'm now at Kong for over nearly 2 months now. Previously been at GitHub for 5.5 years, so I'm coming a bit of an automation DevOps native, and super excited to be participating with you at this meetup and to learn about you and why you guys or girls are looking for mesh, or why you're interested in it. Looking forward to some lively discussions. Thank you.
Thanks, Alex. And with that, I'll pass it over to Sven Bernhardt. He is going to give our Tech Talk presentation today on service integration made easy with Kuma. And Sven is from Optis Consulting. So Sven, would you like to say a few other things about yourself and where you're located?
Yeah, sure. Hi everyone. I'm Sven from Optis Consulting, a German Kong partner. We are located all over Germany, have locations in Berlin, in Gummersbach, in the near of Cologne, in Munich, in Hamburg, in Essen, Nuremberg, also in Poland. At Optis Consulting, I'm working in the business development and innovation team. I'm responsible for technology management, standardization, best practices, and helping our organization and customers to apply those best practices in customer projects. And with that, I think we can start. So service integration as such becomes more and more challenging, especially when we look at cloud native application development. From my personal perspective, today when we build new applications, we should always build them with cloud native in mind. So even if we don't deploy applications to the cloud directly, but run them on-prem, we should nevertheless build them with the cloud native principles in mind, so that we can easily move those application workloads to the cloud and benefit from all the promises that cloud gives us. So with that, having said that that the world is becoming more and more cloud native, what we see is that we are moving away from the classic monolithic application approach to a more distributed application world, which provides more flexibility, more agility with respect to changes, but which also had some challenges with respect to the amount of traffic and the number of moving parts within our application architectures. And this leads to the fact that also the reliability in this, which we get when we need to integrate all those services, because all those services need to talk to each other to depict our business requirements. And since all the communication runs over the network, and the network as such needs to be considered as unsecure because it's not reliable, it's not secure by default. So I need to think of how I can make the communication reliable and secure, and also observable, because the more moving parts in my architecture I have, the more I need to have a central place where I can analyze potential problems and issues within my application communication, right? So we are talking about things like connectivity, reliability, zero trust security, and in the end, observability, which means centralized log management, centralized metrics management, and service tracing. And from an application perspective, from a developer's perspective, this introduces a lot of new challenges, because I need to care about things like security logging, metrics, tracing, versioning, routing, authentication, authorization, rate limiting, and all that kind of stuff, also caching at different levels. So from the edge, then when I connect different apps with each other, and also with respect to the in-app traffic, because one application might potentially build out of 3 or 4 or more parts, which are deployed as standalone containers, loosely coupled, and maybe also with different implementation technologies. So from a developer's perspective, I don't want to care about all those aspects within my specific implementation, right? Because this is something which is not business related. This is, in most cases, it's technical stuff which I need to implement. And I also wanted to have this consistent within over all my applications, so that I have a central place where I can directly see, okay, what kind of security do I have when in case of my service communication, where do I have my metrics, where do I have my logs, and all that kind of things. And also the way how we consume those functionalities, because from a classical perspective, if we think of application connectivity, when we need to connect two applications with each other, we also need to ensure that the appropriate firewall rules were enabled, and this always needs to also include the ops team, which cares about the network. But now I wanted to be agile. I wanted to be flexible from a development perspective. And this also changes the way how we want to handle things, because we don't want a network team to be the bottleneck when we wanted to roll out a new feature, right? So, but on the other hand, we also have the need that the communication needs to be secure, and that I can specifically say, okay, service A is allowed to speak to service B, but not to service C, right? And this is something that a service mesh can provide to developers. First, it provides the consistency of declaring all those aspects that we see here in a central place. So, and we can declare it. We do not need to implement it, right? So we can really focus on the business functionality and declare all the technical stuff above, which is needed to run the application secure, reliable, and robust, resilience. With that, I think I will jump right into the demo, which is basically based on the Kuma demo, which is available on GitHub. So it's a web shop application consisting of a web front end, a back end, and a Redis cache and a Postgres database. So those 4 containers are deployed to my Kubernetes service or to my Kubernetes instance. And what we will do in the demo is we will secure the in-app traffic by MTLS. We will also, I will also show how to use traffic routing for advanced deployment use cases like canary deployment or A/B testing scenarios. And then we will also look into observability features like service metrics. And if we have the time, we will also look into tracing. And with that, I would say we jump right into the demos, in the demo part. So what I have in the very first step here's my Kubernetes cluster. So totally blank. We just have all the regular Kubernetes stuff in there. And in a very first step, we will start and install Kuma, so the Kuma control plane as such. For that, we have a command line tooling called Kuma control. It's very similar to the kube control command, with the difference that Kuma control is read-only tooling, right? So we can use it to install additional features to the Kuma platform. So here in this specific case, we will install the Kuma control plane. And hopefully it's, yeah. So it creates a Kuma system namespace. And if we go back to the Kubernetes cluster, we should see the Kuma system popping off. As we can see here, there's the Kuma control plane. So the container is starting. Now it has been started. That's all. So this is all the magic which is needed to install a basic Kuma control plane, right? Before I'm going to show you more about the Kuma control plane, I will just fire up the installed demo application script, which installs the Kuma demo I showed before. Then I will do a port forward to the Kuma control plane. And in the next step, we will be able to access the Kuma control plane while the application, the Kuma demo application is started. Here we go. So that's the Kuma control plane application. What we can see here is that we run the Kuma control plane, Kuma with one zone. Basically, this will remain one zone within this demo. So you can install Kuma in different architectures. You can install it standalone, or you can install it multi-zone. Multi-zone means if you have to span your mesh over different locations, so your on-prem data center, a cloud data center, and or multiple cloud data centers. You can also put more than one Kubernetes cluster into your mesh, so having more zones then. So for example, you have one Kubernetes cluster on-prem, you have another Kubernetes cluster in AWS, you have another Kubernetes cluster in Azure. Then you can span one mesh with 3 zones and manage the whole mesh with its zones under one control plane, one global control plane. And this is a great thing, I think, for more advanced use cases, because I also believe that hybrid cloud is already a common thing. And in the future, we will see more and more multi-cloud use cases. Meanwhile, as we were talking, we see that we have 4 data plane proxies. So we installed the application, the Kuma demo application, and what happened as we installed the Kuma demo application, each container is proxied by the respective sidecar. This is one basic pattern when we talk about service mesh, is the sidecar pattern. So each container is co-located by a data plane proxy. And this data plane proxy takes all the cross-cutting concerns away from the application container. So we are shifting all the technical stuff like security, like rate limiting, like circuit breaker, or tracing metrics, we taking that from the application level out to the infrastructure level and giving it to the data plane proxies. So as we can see here, we have this Kuma app demo, we have the backend, we have the Redis, and we have the Postgres thing. So far, so good. This is basically the Kuma control plane, and by default, we have one default mesh. We can also have more than one mesh, which we each can configure differently. As we can see, we can add MTLS support, we can add logging, we can add metrics and tracing. Those locality aware load balancing stuff is a feature which you can use if you deploy Kuma in a multi-zone deployment. This ensures that that service resolution is done within a specific zone. Yes. Now as we deployed the application, we wanted to access this application from the browser. Since we deployed this application in our Kubernetes cluster, the thing is that we cannot directly access it because we don't have a respective service which is exposed to the outside world. So as we will see, after this command has been executed, yes, we just have type cluster IPs. So these are purely internal Kubernetes internal IPs, which we cannot access from the outside world. What we need to do is we need some kind of an Ingress controller from a Kubernetes perspective. And in Kuma, with the Kuma control command, we can directly install a gateway. Surprisingly, we can use Kong for that. And then when we fire up this command, the Kong gateway will be deployed as the Ingress controller for my Kubernetes cluster. And after that, by configuring another Ingress rule, we are able to access our application. Side fact here at this point, from a mesh perspective, this Ingress controller is also co-located with a respective sidecar, because everything what I deploy to my service mesh is a service and is handled as such. As we will see when we go back to the Kuma control, it's handled slightly different because it's our Ingress controller, which is external facing. But before we going back to the Kuma control, we will install the Ingress, and looking at the Ingress definition. So what we will, this is just a Kubernetes Ingress definition, which defines what to route where, basically. So a request comes from the outside world to the Ingress address, which is established after I apply this Ingress rule. We are routing everything with path / to the service with name frontend on port 8080. So this is the internal Kubernetes service which we address here. We will apply this Ingress definition. And then after a few minutes, or not a few minutes, few seconds, our Ingress definition will be available and we are able to access this this application. But first of all, I told you about the data plane proxy for the gateway. So now we have 5 data plane proxies. As we can see here, here is our Ingress, but looking here at the data plane proxies, we have standard and we have gateway proxies. The standard proxies are the application proxies. and an application proxy or a normal data plane proxy, let's put it in that way, handles the in and outbound traffic. So everything runs through the data plane proxy, which is depicted by Envoy in Kuma. So, and in the gateway data plane proxy, this inbound listener is disabled. So we just routing the outbound traffic through the Envoy proxy, but not the inbound traffic. Why? Because we have an external facing service which should be accessible from the outside world for every client application, and external applications which we don't have in our own hands, we cannot add to our mesh easily. So this is a different use case here. So this is a typical API gateway use case. Let's put it in that way, because it's an edge communication case at this point. So we wanted to get into our Kubernetes cluster from the outside world. This would be the same if we wanted to communicate to a company's network from the internet. There you have also a API gateway in the DMZ. Same principle here. So meanwhile, our Ingress should be available, and getting the Ingress, we should also see the IP address. Yeah, here's the IP address where the Ingress is exposed. So this is public facing IP address. What happens in my cloud when I apply this Ingress rule is that a load balancer is spawned, which exposes its public IP address to the outside world, and now I'm able to access the Kuma demo app. Here we go. So this is the Kuma demo app, a web shop application where I can browse through the stuff, where I can read reviews and all that kind of thing. So consisting of the 4 containers I already showed you. So far so good. Now we have our application in place. We have installed Kuma. We have a default service mesh. We have installed the gateway as an Ingress controller. We are fine. Now we are good to go. In the next step, what we wanted to do is we wanted to secure the application traffic. And in the first step, we will add MTLS communication so that the services are communicating in a secure way with each other. And second, we will define respective traffic permissions, because when you fire up Kuma, you have, if you go to the traffic permissions, you have allow all traffic permissions, which means basically that the communication is allowed for every service. So every service is allowed to talk to every service, which is for our demo, which might be fine, but in real world use cases, you don't want to have that, because you wanted to specifically define which service is allowed to invoke which other services. Okay, back to my command line. We wanted to add this feature to Kuma, and as you see, when we configure the Kuma control plane, we are doing this completely using the kubectl command line, and this is also great from a CI/CD perspective, because you can directly include everything in your existing CI/CD pipelines and managing everything consistently over all stages you have. So if you look to the mesh definition, so by the way, the mesh is a custom resource definition in Kubernetes. what we'll do is we enable MTLS with a built-in CA, which is fine for our our demo case here. But in real world use cases, you might prefer to put in one of your intermediate certificates from which the application certificates can be derived by using Kong Mesh, which is the enterprise version of Kuma. There is also a direct integration with HashiCorp Vault, and HashiCorp Vault can be used to care about all this certificate management stuff, right? So what we've done, we we enabled MTLS, and using Kuma control, we can also see exactly the same what we see when we use the DUI, because as always with Kong tools, everything is an API. So everything what you can do using the UIs, you can also do using the APIs. So we can see MTLS is in place now. For now, what I also will do is I will delete the traffic permissions, because I wanted to show you how to control the traffic more restrictively. So if the traffic permissions have been deleted and we go back to our application, we are no longer able to access this application, right? Because we basically forbid all communication between services. And now what we will do is we will define respective traffic permissions. If you look into it here, we allow a communication from the Kong proxy gateway to the front-end application. We allow the front-end application to talk to the backend. Here, we allow the backend to talk to Postgres, and we allow, in addition to the backend, to talk to Redis. And we will apply this, and afterwards we should be able to access our application again. Going back to Kuma, so you can see exactly the same what we've seen before. Traffic permissions. Now we have the traffic permissions in place. Going to our application means everything is good again. So what we just did with those few commands, we enabled MTLS for all services that are part of our service mesh, and we defined fine-grained traffic permissions. Done. So this is basic security declaratively with Kuma. Next would be that I will show you the A/B testing or canary deployment support with using traffic routes. If we look to deployments, we can see that our backend application, which we currently have, that we have 3 different versions of it. We have version 0, we have version 1 and version 2. Version 1 and version 2 are currently not established. They don't have any replicas. What I will do now is I will scale them up. So they will come up. And in the next step, I will define the traffic routing policy for that. Because what those containers basically do is, let's imagine in our imaginary web shop, we have the use case that we wanted to try some kind of marketing activities. So we wanted to advertise a specific dress, for example, and give some discount. And on the other hand, we also wanted to give discounts on dresses and shirts, for example. But we wanted to elaborate on that. We don't want to have too much people to profit from this kind of special offering. And so we wanted to have, let's say, 70% going to version 0, 20% to version 1, and only 10% to version 2, which would offer discount on shirts and dresses. If we look to the respective traffic routing policy, we can define, okay, it should be applied to all traffic which goes from the front end to the back end. And what we will do is we want to split the traffic by a percentage weight, so 70% to version 0, 20 to version 1, 10% to version 2. So this is basically layer 4 TCP based routing. But with Kuma 1.2, there was also introduced layer 7 routing, where we can implement more sophisticated routing policies based on, for example, HTTP headers or HTTP paths. So we have more possibilities, and we also do not need just to configure splits, but we can also manipulate the requests by injecting headers, for example. So the traffic route policy is quite powerful. For now, let's stick with this for this use case. We are applying the traffic route. And after that, when we go back to our web shop, we will be able to see that, and I will put here an automatic refresh. So this was the version 2 with, again, the version 2, this is the version 0, version 0, version 0. Let's come on, version 1. We wanted to see you. There's the version 1. So this basically is the point. So as I defined in my traffic routing policy, the traffic is automatically distributed by Kuma or splitted by the mesh as defined by the respective policy. And by doing so, I can implement advanced deployment patterns like canary or A/B testing. And this would be an example for the A/B testing stuff where I just wanted to elaborate on a specific business idea I had. Now, I think I will do one more, but I need to keep the time into an eye on the time. But I think we will do the metric stuff. So on the mesh, as you've seen before, we can also enable the metrics, the tracing stuff, and also loggings. To do that, we can use the Kuma control tool again to install metrics. And what happens is that it installs the Prometheus stack, basically. So Prometheus, the alert manager, and Grafana to my Kubernetes instance. I don't need to do that, but for my demo, since I don't have another Prometheus instance running anywhere, this is perfectly fine. But you are also able to configure your existing Prometheus environments to collect all the metrics from within your service mesh, right? Additionally, what I need to do, you might know what I wanted to say. You need to configure your mesh accordingly. First of all, we need to define the respective traffic permissions, because also since we deployed the Grafana stack to our mesh, we also need to define the respective traffic permissions to allow the traffic. Otherwise, the services cannot communicate, and then we are not able to see anything. So we apply the traffic permissions. And after we applied the traffic permissions, we have to configure the mesh accordingly, because so far, as we look into Kuma Kettle, we just have the MTLS in place. Now we apply the metric stuff. And after that, we tell Kuma to collect all the metrics for the services that are annotated respectively. So with the respective scrape configs. Fortunately for the Kuma demo, this is already done. So we do not need to do anything here. What we need to do is that we need to port forward, not the Jaeger stuff. We need to port forward Grafana, so that we can access the Grafana dashboard from my browser. Here we go. The cool thing is that Kuma already provides a rich set of Grafana dashboards, giving us transparency over what's going on in our mesh. So for the control plane, but it gives us also insights into our data plane proxies, so we can look into all the data plane proxies here. So the Kuma demo backend, which is online for nearly 25 minutes. So the version 1 is not that long online, because we just fired it up before for the demo, and we also can see how many traffic arrived at the specific services. So this is the data plane overview. And what is also very interesting from my perspective is the information about the traffic flow from, let's say, the Kuma gateway to the front end. So, or you can also observe the traffic which goes from the, let's say, from the front end. There's the front end. There's the front end to the back end, and to a specific back end. So this is a quite nice set of available dashboards. And here we have the control plane overview, which is especially important if we look into multi-zone deployments, because then we have one global control plane and we have also zone control planes established. So we have an overall use for the data flows and also for the control plane flow, right? So, and for now I think we had 25 minutes nearly for the demo. And what we did so far is quite impressive, because we applied for the application without touching any application implementation. We established a secure communication between the different application parts. We defined what kind of communication is allowed. We also applied A/B testing using traffic routes, and we fired up central metrics collections with Prometheus and Grafana, but just configuring our mesh. All right. The same applies if we now configure additionally the tracing stuff. So so then we have the insights from a Jaeger perspective about the traffic traces to discover potential performance bottlenecks and all that kind of things. So always the same approach here. Yeah, I think with respect to the time and also to give room for questions, I would skip the demo about the service tracing now. Yeah, open up for questions if there are any.
Thank you so much, Sven. So yeah, we have the benefit of having a smaller, intimate group today. So feel free and speak up. If you have any questions or if you wanted Sven to go over that last demo, let us know. If you're shy, feel free and enter in the chat as well. And stick around because in just a few minutes, I'm going to have a couple of giveaways for attending today, some gift cards.
I have a question with regard to the infrastructure requirements. So Sven, can you elaborate a little bit of, what typical infrastructure requirements Kuma needs in terms of server infrastructure and those kind of things?
Kind of server infrastructure. Kuma as such is platform agnostic, so we can deploy it to any infrastructure. So we can deploy it to Kubernetes. We can deploy it to VMs. We can deploy it to nearly every Linux operating system. From a resource perspective, it depends highly on which features you enable. As you've seen, if you fire up a complete Grafana Prometheus stack, it consumes respectively more resources. But from a basic setup, control plane setup, the footprint is not that much.
Okay, and in terms of scaling, so how does the system scale? So what are the scaling parameters, and who's taking care then of those parameters if they need to be extended? So let's say you have more applications that need to be managed. Is that in scaling indicator, or in which sense does this application need to scale into other, let's say, physical machines or something like that?
Since a service mesh is a distributed architecture, scaling is not really a problem, because the more applications you have, the more data plane proxies you have. To be honest, I'm not sure if you have limitations on how many data plane proxies can be handled with one instance of a control plane. But if you look to, for example, for Kong Connect provides a SaaS control plane model. So you as a user, you are no longer responsible for handling all the control plane stuff, but it's handled by Kong. So it's a SaaS offering. So you just roll out the data plane proxies from this cloud-based Connect platform, and so scaling the control plane is no longer your issue. So it's done by Kong completely. And as I said before, in an on-premise world, I cannot seriously give you an estimation on how many data plane proxies are applicable for one control plane instance.
Okay, and you mentioned those data plane proxies. How many? Again, I'm not sure whether that's even a parameter that is taking into account. But how many applications are usually managed by one data plane proxy? Is it one-to-one or one-to-n or?
It's one-to-one. It's always one data plane proxy per application.
All right. Okay.
So as we've seen in the demo, we had this cloud native application. This cloud native application consists of 4 containers, and each container runs in its own pod. And what happens is that per pod we inject a sidecar. So if you have more containers within one pod, you will have one container per pod, because within the pod communication happens using localhost, right? In a Kubernetes world. But if you go in the VM world, you will have a one-to-one relationship between the data plane and the respective application.
Got it. Okay, thanks.
Hello, I may have one question. Like, let's say you already have a microservice architect. How easily to integrate or to deploy Kuma as a solution for your service mesh? Like, can you inject Kuma in and create your mesh, or how easily is that?
It's quite easy. So you need to install the Kuma control plane basically in the first step, and then you need to annotate your Kubernetes namespaces where your applications are running. So there you need to annotate it with sidecar injection enabled. It's just an annotation on the namespace level, and afterwards you have to re-roll out your pods, and then the sidecar is injected.
Cool, thanks.
Any additional questions?
So that would only work if I basically have control over the container, or access to the container to the cluster respectively, right? So, or with other words, if there's an external service, like external SaaS service, and I would also like to basically include that API from that SaaS service into my mesh, would that still be possible, or how would I do this with that solution?
That's basically a different use case, because this is not a use case for service mesh. Because service mesh or prerequisite for service mesh is that you have access, that you own the services. If you wanted to reach out to external services, or if you want external services to get into your service mesh, this is a use case for an API gateway, because you are crossing trust domains at this point, right? So for accessing external services, you use an API gateway, and then you can make use of that.
Okay, got it. Yeah.
It's nearly the other way around, as we've done in the demo with the gateway to get access to the front end application from the outside world. So it's the other way around.
Sorry, I didn't get that. So what do you mean the other way around with the
other way around? So because what you can do is you can define this external service. You can establish an API gateway for external facing apps which you wanted to consume, but that are not part of your organization, right? And then in the API gateway, you can define a service which points to the external API, and then this you can call out to the external API using the API gateway, which is part of your application, for example.
Yeah, okay.
But you are not able to include this external application to your mesh directly. That's not possible basically, because in a service mesh, the communication doesn't happen between the services anymore, but it happens just between the data plane proxies. So applications are no longer talking to each other directly, just via the proxies.
Yeah, makes sense.
Mm-hmm.
All right, we're just about at the top of the hour, so I wanted to do my giveaway very quickly. And Sven, if you want to share your email or a link to where people can contact you, perhaps in the chat, if they have any more questions. And let's see, this is crazy coincidence. I selected the winners right before because, you know, I did the random generator and everything, and wild coincidence, it is the two people that asked questions. So, so Peter Han and Mikhail Dorme, I will email you, and you both won $50 gift cards for attending today. So thank you so much.
Well, thanks a lot.
No problem. Those will come from Gifted, so keep an eye out. Sven just added his email address, so if you have any additional questions about Kuma or Kong Gateway or anything, you can send those over to Sven. And thank you all. Oh, and there's his Twitter as well. Awesome. So thank you all so much for attending today. I also posted, we've done a whole bunch of videos on Kuma in our live stream called Kong Builders. So I posted that in the chat. If you're interested in learning more, go back to the first live stream, and that's where we kind of start talking about Kuma as well. And go download Kuma today. It's open source, it's free. Go check it out at kuma.io. So any final words, Sven or Alex?
Nothing for me. Thanks everybody for joining.
All right, everyone have a great rest of your day, and we hope to see you at the next meetup, which will hopefully be in person. So keep an eye out on our meetup groups. And if you found this in another way, make sure and go check out the Kong meetup groups and join one in your area. Thanks, everyone. Hope you enjoyed it.
Thanks, guys.
Bye. Thank you very much.